get started. Now I would request you all to keep your videos on. The reason being I would be able to interact better and will request you guys to make sure that you only raise your hand, ask questions when it is relevant and important. Okay, don't ask questions for the sake of asking. Alright, so what did we learn yesterday? Or what were we trying to learn yesterday? Anybody remembers? Yadikshita.
Irrational numbers.
Irrational numbers. So, or you can say irrational numbers or irritating numbers. Numbers that you don't like much. Yeah? Kind of? Okay. So in today's class we'll deal with different scenarios of irrational numbers. Try getting a little more comfortable with them. Try figuring out what are the interpretations that we can derive from those operations, yeah, and see if that gives us some clue with respect to how to use them going forward. So first of all, a very simple example, a very simple understanding that we have tried building with irrational number is, irrational numbers are the numbers that cannot be represented as fractions. Meaning, if I have a number which I can represent in this form, a by b, then this is not an irrational number. Okay? If I can represent any number in the form of a by b, where a and b are integers or prime numbers, whatever it is, then this is a rational number. So if I'm talking about 6, I can write this as 6 by 1, or I can write this as 12 by 2. This is a rational number. But if I have this, I cannot write this in the form of a by b, or like a fraction, and that's why they are called irrational numbers. Okay? So in today's class we are not going to study anything, okay? We'll just do time pass. We will interact, we will talk, we will waste each other's time and see that still enforces some learning. So, never take me seriously if I'm cracking bad jokes, okay? Next 1 hour I'm going to make sure that you guys are learning something. We don't have a choice. Now, let's look at this, and this. And tell me, among all the 6 numbers that you see on the board, square root 2, square root 3, square root 4, square root 5, square root 6 and square root 7. Are they all irrational numbers? All? I'm seeing some yes and some no together. Are these all irrational numbers? I can see Vivan's 3-dimensional movement. Okay. Okay, now the question is, can I write this in the form of a by b, like a fraction? Probably I cannot. Can I write this? I probably cannot. So this seems to be a candidate for irrational number, these two. How about this guy? Square root of 4. I can write square root of 4 as square root of 2 square. That makes it 2. That I can write as 2 by 1. This is not a irrational number. Got it? So any square root scenario which converts into a whole number or natural number or a fraction by itself, that is not an irrational number. Now let's look at one more scenario. If I'm talking about, is this an irrational number? Why? See, Dikshita is first saying no, then saying yes. Yeah, Anirudh, tell me. Joel, is this an irrational number or not? I'm making you guys think.
Yes, I think.
Why so? No, so I will not take anything on its face value. You'll have to explain that to me, okay? Okay, I'm giving you 1 minute to think about it. Let me see what Arav is trying to say. Arav Advik. Yep.
So I think it is not an irrational number because, like, if you think about it, 1/9 square root would be like 1/3 square, which would be 1/3, which is not an irrational number.
Irrational number. Okay, that's one justification. Let's see what Joel has to say.
I think it is because if it's the square root of 1/9 is 1/3 squared, then it will equal to 1/3,
Yeah.
and then 1/3 can be put in fraction form. So,
1/3 it's actually a fraction.
yeah.
Yeah. Okay. All right. So, as you guys said, right? 1/9, I can write this as 1/3 squared because 9 can be written as 3 squared. So, square root of this, or I can write this as 1 squared by 3 squared, and square root of this will become 1/3. So, this is a fraction. So, this is a rational number. So now let's look at some more behavior. If I add two irrational numbers, yeah, Dikshita, you're saying something.
So for 1/3 we do put square 2, right? So why do I have to put 1/2, 1 to the power of 2 for the 1?
So see, if I have this 1/9, I said this is 1/3 square. Now imagine this is like a square by b square. Okay. If I do a square root of this, then it gives me a by b. Here, if I just write 1, you might think that okay, I changed when I took out the square root sign. 3 square became 3 because it's a square root. How about this guy 1? Right? So when you have a square in the numerator and denominator both, and you take out the square root, this is what it becomes. If I say a by b square root equals a by b, this will not be right. You will say that okay, no, here you have a square and you did the square root, it became b. Understood? Why this guy? So just to make it look uniform, I made it 1 square so that it doesn't look like I'm doing any bias with this guy and I'm ignoring this guy. Yeah? But in general formula, in general way you should look at it, if you have numerator and denominator and you're taking square root, you can simplify this only if both are squares. Yes, Advik.
I'll leave and then I'll join back in 2 minutes, okay?
Sure. Yep. Everybody with me? Now, let me ask you guys again. Today's class, I'm not in a mood to teach anything. I'm only going to challenge you guys. Now, the first challenge for you guys. If I multiply two irrational numbers, will my outcome be irrational or rational? So I would suggest, I would advise not to raise the hand immediately. Let me read the question one more time. Digest the information, process the information, and again, you guys are giving me reason to annoy you guys further, right? I always say, this is the thumb rule that you have to follow. trust, read, analyze, and then Nike. I get really disappointed when I see everybody going to Nike straight away. Meaning you're not analyzing the question, you're not reading the question, and you're trying to solve it. So anybody who raises hand quickly doesn't make me happy. Take your time, think about it before you raise your hand. Okay? There's no race, nobody is going to win the race either. Okay. Yeah. Now let me repeat the question. My question was that if I multiply two irrational numbers, what will be my outcome? Will it be rational? Will it be irrational? And why? And give me good description or give me a detailed explanation of that, assuming I am a fifth grader who doesn't know much about things. Yep, yeah, Vishal, Arav, Advik, whoever wants to go first, it's okay. Now you can go ahead. Or even Lohit. Lohit had raised hand. So yeah, Lohit, I will let you speak. You have not spoken much so far.
I think it will equal rational number because, for example, like if you do 1 by 3 times 1 by 3, it's like 1 by 9.
Okay, and that becomes a rational number. So if you are doing square root of 1 by 3 multiplied by square root of 1 by 3, that will give you 1 by 9. Square root of 1 by 9, that will be 1 by 3. So multiplying two irrational numbers will give you a rational number. That's what your stand is, correct?
Yeah.
Okay, that's one point of view. Let's see what Arav has to say.
So, like a rational number can be like written as a fraction with like a numerator denominator, but not with the zero. So that's what I also have conclusion. Because it's supposed to make sense that if it's irrational, then shouldn't the rational like be like a different digit then? Or should it be like yeah. That's what I like figured. That's what I noticed about when I.
So I'll request you to stop here, okay? One quick thing here, okay? And again, I'm not being sarcastic here, but take this as an input. Now, whatever you said, that is recorded on the video, okay? So after the class, just watch the video and hear your part of what you said, and see if that is conclusive for you or for anybody. Because I can keep on blabbering for next 1 hour without giving any clue to any one of you, okay? It's very important for all of us, like as a student, as teacher, whatever we say, is there conclusion coming out of it? Is it something that is easy to understand? So that's why it's very important to structure your thoughts and then share. Because whatever you are going to teach, I said I'm a fifth grader, I don't know anything. And whatever you taught me, I did not understand anything, trust me. Okay, Advik. Advik, unmute yourself and let's see.
I think a rational number can be expressed by like two integers as like in a fraction or like a decimal or a percentage.
Let me ask this question, a more simpler question. Did anybody understand what the question was? My question was, if I have two irrational numbers, if I multiply them, will my output be a rational number or irrational number? That is what I'm trying to get to hear from you guys. And I haven't heard anything straight enough. Let's see what Dikshita has to say.
I think it's rational because if we multiply 0.5 times 0.7, we get 0.35.
So what will be your answer? So let's say I'm saying I have two irrational numbers. Let's say this is my one irrational number, this is my second irrational number. If I multiply them, will I get an irrational number z, or will I get a rational number like this? That's my question.
Is it irrational or rational?
I said these are x and y are irrational numbers. When I am multiplying them, will my output be a rational number or irrational number? That's my question. Shanvi, tell me your point of view and you have to explain me like I'm a fifth grader, okay?
I think it 2 times the square root of 2, that is 2.
Okay, that's one point of view. Let's see what Vishal has to say.
An irrational number times a rational number would be irrational. So like, for instance, square root of 2 times square root of 5, it'd be something like that, not a proper integer. It won't be like, it would be in the decimals like 3.1 or something like that. So
Okay.
like pi, something like that.
Okay, let's see what Dikshita has to say. One last answer and then I will give you guys my gyan of the evening. Yeah, Dikshita.
So if we do 6 squared times 5 squared, we get 6 root times 6 5 root, we get 5.7.
So, okay. Yeah, Anirudh.
I think an irrational number times an irrational number would be an irrational number because, like, let's take an earlier example, square root of 2 times square root of 2. Like, if you simplify that, it would be like 1.4 etc. times 1.4 something. And I don't think that's exactly 2.
Okay.
It's an exact fraction.
Okay, so here comes the thing that you guys need to be aware of. Interesting part of this whole thing is it's not straightforward. It depends on what you're dealing with. Okay? Meaning square root 2 is a rational number, square root 3 is also a rational number, square root 7 is also a rational number, square root 11 is also a rational number. Yeah? If I'm multiplying two distinct, that heart is a broken heart. Don't play with emojis. So if you're dealing with two distinct irrational numbers, then the likelihood of that being irrational is more. If you're talking about square root 2 multiplied by square root 3, by no means it can be irrational. It will end up being square root of 6, which is another irrational number. If you're talking about multiplying square root 2 with itself, that's the only scenario. It will become this or a rational number. So there's no silver bullet which tells you that okay, you multiply two irrational numbers, your answer will be irrational number. No. You have to look at what are the numbers that you're dealing with, and depending on that. However, a generic assumption that you can build based on what we are seeing here is, if the irrational numbers are different, then the chance of the outcome being irrational is more. If they are the same, then only that will be irrational. Does that make sense? Yeah? Yes, Dikshita.
I can understand.
So I'm saying there is no one answer for this. Meaning, if you are multiplying two irrational numbers and they are different, meaning I'm multiplying square root 2 with square root 3. This is a rational number, this is a rational number. When I'm multiplying these two, then my answer is square root 6, right? It gets multiplied. This is a irrational number. So if you're two numbers that you are multiplying and they are different irrational numbers, then the multiplication of that, it's highly likely that it will be an irrational number. If you are multiplying them with itself, if you are multiplying the same irrational numbers, then only it will become a rational number. Okay?
So it's like 2 square root times 3 square root. Are they like irrational numbers?
Yeah, it is. Because look at this. See, simple thing is this. Okay? Let's say if you have the square root of a multiplied by square root of b. What it will become? It will become the square root of a into b. So there is no square here. If I have a square root of a multiplied by square root of a, then it becomes a square root of a into a, which is a square. So you can knock it off. Yeah? So that's why I was saying, if your two inputs are different, if the two irrational numbers are different, then multiplying them, it's highly unlikely that it will become a rational number. 99% times it will not. Okay?
Okay, sir.
except for the scenarios where this multiplied by this becomes a this. Now tell me, is there a possible number that you are aware of where you multiply a and b which becomes a c square, meaning a and b are two different numbers? Let's say 5 times 7, 5 and 7 are different. 5 times 7 is 35, not a square. If I say 5 times 20, yeah, I have an example here. Square root of 5 multiplied by square root of 20. What will it become? Square root of 5 into 20, which is square root of 100, which is nothing but 10 square. Yeah? So here the basic thumb rule is, if you are multiplying the irrational number with itself, then it will become a rational number. If you are multiplying irrational number with some other number, it's highly unlikely that it will become a rational number. It will remain irrational. Okay? Two different irrational numbers multiplied with each other remains an irrational number, except for the unique scenarios like this. Yep. Vishal, Arav, Advik, Lohit. Making sense so far? Sanvi, Joel. Okay. Now, who's crying? I saw an emoji with that is Arav. Is it because I told you to think and then answer? Yanrud.
Wait, so you know the golden ratio, right? How it's like a irrational number?
I don't remember having come across that term, golden ratio. You might want
So
to.
basically, it's like an irrational number with like 1.618 something like that. If you multiply it by itself, would that still be a rational number?
Yeah. So any number, see, any irrational number that you multiply with itself, that will become a rational number.
Wait, but if it's like a never-ending, wait a second.
I'm not talking about scenarios like, see, the problem happens if you do a square root of this and that becomes 1.41 something, okay? I'm not converting this in the first place. I'm saying that I'm taking it in the raw form. And then if I have to multiply this with itself, because here in this case what's happening? You are doing approximation, you are not dealing with the exact value. So that's why when you multiply this with itself, you will never get exact number. But if you keep the raw value intact and then you deal with it, then you're fine. Because what happens is, even if you look at pi is 22 by 7. If you're treating this as a 22 by 7, you're fine. But what happens is we start converting this and it becomes 3.1416 and it's never ending. It continues. But we end up stopping at some point by doing some estimation or approximation. So you have already injected a problem. Now even if you multiply this with itself, it will never give you 22 by 7. Because you have done a little bit of tweaking in the number. Right? So in summary, even if let's say it's a never ending thing, okay? And you have a recurrence on the top of it. Let's say you got some number which is, let's say 1.1417, something like this, and then you have a recurrence on, let's say this one. So if you are looking at this number alone, this number has no meaning for itself. The reason being, it's not an accurate number in the first place. Because it could be 7 and it will go till infinity. You might say, okay, I'm lazy now, I will change it to 8. So you have anyways changed the value of it. So even if you convert this to a fraction, you're still doing approximation, so you'll not get the exact value. What I'm saying is, when I said rational number, when I said irrational number, I'm talking about square roots primarily, which is absolute prime numbers. If I'm talking about prime number like this, and if I'm multiplying this with itself, I'm good. This will give me a square root of 7 square, and that becomes 7, which I can write as 7 by 1. It's a rational number. Is that making sense? And here you guys will have to use a lot of judgment, okay? I mean, there's no one thumb rule. But I was saying the indicative view. Let's say if you get a question which says, I have two different irrational numbers. If I'm multiplying them, will I get a rational number? And as soon as you hear that there are two different numbers, two different irrational numbers, that means it's highly unlikely that it will become a rational number, because it's not going to convert as a square. But you still might want to do calculation. Yeah, Pranav.
Sir, my friends are watching me. Is that okay?
Yes, why not?
Okay.
And now, I mean, be it 5 of you on the screen or 6 of you on the screen, doesn't hurt as long as you are paying attention and that's not causing any disturbance for the class. So it's fine. Now, let's look at another scenario. So again, here in this case, yep. Yeah, go ahead. Vivan. Oh, sorry, Pranav was saying something?
No, sir, it was Baslet.
Okay. So the first theory that we were trying to explore was, if I am multiplying two irrational numbers, what will be my outcome? Will it be rational or will it be irrational? And there's no straight answer to that. However, there are two different things that we saw. If the irrational numbers are same, multiplying them will give us a rational number. If they are different, then most likely it will be irrational number only. It will never become rational, except for the scenarios where multiplying those two unique numbers becomes a square. Now, let's say if I have irrational number 1, if I add one rational number and one irrational number, what will it become? Will it remain rational or will it become irrational? Meaning, I have a 5 and I'm adding square root 3 to it. Will this become irrational or this is rational? Yadvik. Again, repeating my question. If I am adding a rational number with an irrational number, will it become rational or will it remain irrational? Yadvik, go ahead. Quick. You cannot raise hand and make me wait for 2 minutes.
I think that's a Ross, not me.
Oh, it's Arav? Yeah, Arav, go ahead.
I think you become a irrational number because there's like nothing to, because 3 is already simplified and can be in 2 powers and 5 plus.
Simple answer is, this cannot be represented in a fraction form, because I have one part as rational and one part as irrational. By adding or subtracting a rational number from a rational number, the outcome is always irrational. Be it addition or be it subtraction. When you add or subtract a irrational number from a rational number, it becomes irrational number. Is that okay? Yeah?
Yeah.
Now, what will happen if we added, subtracted and we multiplied also? Let me just think. If there is a scenario that I'm missing here. Adding, subtracting is fine. Multiplication is also okay. Let me see if there is a topic that I had considered which I'm missing here. Missing to recall. Okay. I think no, this is fine. So now let's look at a scenario where you have am I running out of ideas? So okay, let's do a quick recap. So we learned what is irrational number. We learned how to deal with different operations. So if I'm multiplying two irrational numbers, it can become a rational if they are same. It will remain irrational if they are different. 90% of the cases, except when the two irrational number becomes a square. When we are adding any irrational number to a rational number, the outcome will be irrational. If I'm subtracting any irrational number from a rational number, the outcome will be irrational. That part also we saw. Now let's we still have 20 more minutes. So let's pick up another topic, okay? I don't want to keep on blabbering for rational irrational. That will not be very interesting. So let's pick up our next topic, and that I will decide. Arav, you will not have the opportunity to decide a topic. Put your hands down. Unless you have a question on irrational numbers.
I actually do. So does irrational numbers, all those subjects relate to integers, all those types of numbers?
Say it one more time in a simpler way. Or maybe with examples so that it becomes easy for me to understand.
Okay.
Now say it in a simpler way. You are still not done yet. What was your question? You have to repeat in a simpler way. Think and let me know. In the meantime, I'm deciding the topic for next class.
It's fine. Never mind. I can find that question on
Okay. So the summary of this thing that we have learned, right? See, we saw different types of numbers. We learned what is okay. Yeah, I now I recall what I wanted to teach you guys. Okay. So we learned what is irrational number, what is a rational number. Now I told you guys that square root 2 is a irrational number. But why will you believe that? Not because I have more gray hairs, right? Square root is not is an irrational number. If I ask you guys to prove, how will you prove it? Any thought?
What were you saying?
I'm saying I have been telling since the beginning of the class that square root 2 is a irrational number, square root 3 is a irrational number. But why? If you have to prove that, do you know how to prove it? Okay, let me try proving it, okay? And stop playing with emojis, okay? Not much appreciated, okay? Now, I'm saying square root 2 is an irrational number. First of all, let's understand what is the basic definition of irrational number. Any number is irrational if it cannot be represented in this form. Yep. Square root 2 will be irrational only if it cannot be represented in this form. Agreed? Everybody? That's the only raw concept, that any number will be an irrational number if it cannot be represented in this form. Yep. Now let's play with this. I'm saying square root 2, we have to prove that this is irrational number. But let's assume that this is not irrational, this is a rational number, okay? Let's assume that. Let's go against the wind. I'm saying that this is a rational number, okay? A and B. So square root 2 equals A by B. I'm trying to prove myself wrong and say that this is not a irrational number, this is a rational number. what it would mean? That means A will be equal to B into square root 2. Agreed? Yeah? That means A square will be equal to B square into 2. Okay? Now, that means A square can be divided by 2. Correct? Here A and B are my co-primes, okay? Both are indivisible numbers, okay? I'm saying that square root 2 equals to A by B, where A and B are co-primes, meaning they cannot they cannot be divided by each other, okay? Okay? So, from this, we assume that this is A by B, where A and B are not divisible by each other. These are co-prime numbers, okay? That means from this equation I got A equals B times square root 2, or A square equals to B square into 2. From this we found that, okay, fine. That means A square can be divided by 2. Yep. Up to this much is okay, right? Everybody with me? I just assume that this is a rational number which equals A by B, and A and B are two co-prime numbers, and then A equals this value. So that means A square can be divided by 2, because A square equals 2 multiplied by something. That means A square divisible by 2. Now there is one more theorem. There is one theorem which says if I have a prime number P and if it can divide A square, this prime number can also divide A. Meaning, if a prime number is a factor of A square, then it's also a factor of A. This is one theorem that is given as the base for doing the calculation. Okay. So here if you relate, that means A square equals to B square into 2, that means A square can be divided by 2. Now if I relate this with this theorem, meaning if a prime number can divide A square, then this can divide A also. That means if A square can be divided by 2, that means A can be divided by 2 as well. Again, doing a recap, we are trying to prove that this is a irrational number. We went with the opposite theory. We said, okay, no, this is not irrational number, this is rational number. Let's look at it. If this is rational number, that means it will be A by B, where A and B are co-primes. Which means, now I am doing the calculation here. So square root 2 equals to A by B, that means A equals B into square root 2. Or A square equals B square into 2. From this we can see that A square can be divided by 2 because it's a factor here. And there is another theorem which says, this is a factor, theorem of co-prime, which says if a prime can be a factor of A square, that will be a factor of A also. Okay. Now from that we see that, okay, now A square can be divided by 2, that means A also can be divided by 2, meaning A can be divided by 2, meaning A equals 2 multiplied by something, let's say C. Okay. That means A square will be equal to 4 into C square. I'm just doing a square on both the sides. So A equals to 2 into C. C is another number. We don't know what it is. Okay. We just know that A can be divided by 2. That means A equals 2 times something. Yeah. Are you guys getting bored and feeling sleepy now? No? Okay. So from this assumption we found that A equals 2 into C. That means A square equal to 4C square. Here we found A square equal to B square into 2. Here we found A square equal to 4C square. That means A square, from here we are getting as 2 into B square, and from here we are getting A square equals to 4C square. Okay. That means if you take these two, 2b square equals to 4c square. I'm just comparing these two because both are equal to this. So b square equals 4 by 2 c square, or b square equals 2 c square. Now, what do you see here? We said b equals 2c square. Now, what do you see here? We said this a and b are co-primes, meaning a and b cannot be divided by each other. But from this, what do we? Let me just go a little slow here. We found these two things. That means here we are getting a square equals to 2b square, and this equals 2b square equals 4c square. So b square equals 2c square. So from this, okay, yeah, b by c, sorry, b square by c square equals 2. So b by c equals 2. And from here we see okay, yeah, I got it. So from this, okay, let's go a little slow here. So here, okay, again starting from beginning, okay, I'll just take 2 more minutes. This one we are trying to prove this is irrational, and we assume that this is not irrational. That means this equals to a by b, where a and b are co-prime, meaning there is nothing you can multiply with a to get a b, or vice versa. They are independent prime numbers. So from this equation, a equals b into root 2, and then we got this. And this theorem says, theorem of prime says, if something can be a factor in a square, then it will be a factor in a also. So if here from this we see a square can be divided by 2, meaning 2 is a factor in a square. So a square can be divided by 2. So a can be divided by 2 also from this theorem. So that means if a can be divided by 2, meaning a equals 2 into something. I am saying c. So from this we get a square equal to 4 into c square. So one theorem says one equation says a square equal to 4c square. Second equation says a square equals to b square into 2. That means this and this are same. So 4c square equal to 2b square, or c square by b square equals b squared by c square equals b square by c square. So this comes down. So 4 by 2 equals 2. So b by c will be square root of 2. Now what do you see? B by c is square root of 2 and a by b is square root of 2. That means a by b equals b by c. And from this, what do you see? B square equals to a into c. So we are saying that here. So b square, yeah. So b square by a equals c. So from this, what we are saying is there is something I can divide. There is something common here. So there is a factor here which I can multiply with a, which gives me b square. So there is something common between these two, which is different from what we are assumed. We assume that these are co-primes, meaning there is nothing common between them. There is no factor here. But by doing all this, we realize that b square by a equals c, meaning multiplying something with a will give me a b square or a b, which is c. So this actually denies what we assumed. That means we went with the assumption that this is square root is a rational number, meaning it can be converted to this fraction form. But actually this assumption was wrong, because by going through all that we found that okay, a becomes this. So a square has a factor as 2. That means a also will have a factor of 2, and a is a factor of 2, meaning A into something is C, and when we put this value here, we find the relationship between B, A and C, which says B squared by A equals C, meaning multiply something with A, you will get a B square, or divide B squared by A, you will get some prime number, which is against what we assumed. We said that A and B are co-primes, meaning there is nothing common between these two. So that means this proves that the square root 2 is irrational number. Now you will say that, sir, you played with all the jargons and got us confused, and you are saying that believe me that this is irrational number, right? So let me just repeat what I said. We have to find out whether square root 2 is an irrational number or not. And we were trying to prove that this is irrational number. We said, okay, fine. For the time being, let's assume that this is not irrational number. This is rational number. So we put this way, wherein A and B are two co-primes, meaning there is nothing common between A and B. There is nothing common between A and B, meaning if I multiply A with something, I will not get a B. This is what we assumed. But after doing all the calculation, we found that if we assume this, we found that it became A square equals 2 into B square. That means 2 is a factor, meaning you multiply 2 with something, you can get A square. And there is another theorem of prime factorization which says if something is a fraction of A square, meaning something can divide A square, then this can divide A also. And that is how we relate. Okay, fine. If 2 can divide A, that means 2 into something equals A. And from this we took A square equals, when we did the square on both the sides, it became 4C square. So this 4C square is equal to 2B square. So 2B square equals 4C square. So from this we found that B by C gives me square root of 2, meaning this value is same as this value. So my B by C is equal to A by B. That means this fraction and this fraction are same, meaning B square equals A into C, which was our understanding. We assumed that A and B have no relationship among them, but by doing all that we found that B square is a multiplication of A and C, meaning you multiply A with something, you will get a B. Wherein we said that A and B have no relationship here, they are co-primes. So that got proved wrong, and that is why we are saying that whatever we assume that this is a rational number, that was not right, so this is a rational number. Same way you can prove square root 3, square root 5, whatever. You assume it to be rational, do the calculation, apply this theorem of co-primes, and then you will get the same thing. Yeah? Yeah, Advik, you have a question? Or Arav?
Teacher, can we, so I actually have two things. In my math book, it said like it uses P and Q. Can I do that too?
Yeah, sure.
Okay. And second, is there any more formulas for irrational numbers?
There is no formula as such. It's all about dealing with different options that you have and then applying the basic relationship among them to kind of solve it. Because if you try applying a formula, your irrational numbers don't have any definition. Okay, irrational numbers are off the roof. It can go any possible way that you can think of. Yes, Anirudh.
What is C again?
What is that?
C.
C is nothing but we came to this point, right? We said, okay, this is a square root. We are trying to prove that this is irrational. But we assume that no, this is not irrational, this is rational. Let's assume for the time being. So we assume that. So square root 2 is a rational number. That means it will be in the form of A by B, where A and B are co-primes, meaning they have no relationship. Okay? They have no factor. There is nothing like multiply with something and you will get a B. Okay? Or multiply B with something and you will get a. So that is what we assumed. Okay? Like if you talk about 2 by 4, this is not a co-prime. these two are related, right? If you convert this to 1 by 2, now this is a co-prime. This is the right fraction actually. Right? This is a simplified form of the fraction. If you look at any fraction for that matter, if you talk about 16 by 9, this is a real fraction where you cannot simplify it further. So we are saying that these are co-primes, meaning these two have no relationship. You cannot multiply 9 with something to get a 16 or vice versa. Yeah? Now, here in case of C, what we are saying is, we assume this and we got to this place, that a square equals to 2b square. That means 2 is a factor of a square, meaning you can multiply 2 with something to get a square. Okay? Anirudh, are you with me? So 2 is a factor of a square, meaning from this equation we found that multiply 2 with b square, you will get a square, meaning 2 is a factor of a square. Yeah?
Yeah.
Now, another theorem of co-prime says that if any prime number is a factor of a square, then it will be a factor of a also. So we applied that here. That means if 2 is a factor of a square, meaning multiply 2 with something, you will get a square. Then this theorem says multiply 2 with something, you will get a also. That's the theorem that we are applying here. So multiply 2 with something, you will get a. So I assume this is C, because you were using a and b here. This is my another variable that I assumed. Does it make sense?
Yeah.
Yeah.
You hear me?
Yeah, now I can hear you. So basically we assume, so from this theorem we found that, okay, fine, if 2 is a factor of a square, then 2 will be a factor of a also from the theorem that we know. So that we just applied that here, say okay, fine, 2 is a factor of a, meaning multiply 2 with something, you will get a. So let's say it is C. So 2 times C gives me a. Now you square this side and this side, you got 4c square equals a square, and here you had a square equal to 2b square. So it became 4c square equal to 2b square. From this you got b by c, b square by c square equal to 2, or b by c equals square root of 2. This is exactly the same value that you had here. You had assumed that b by c is square root 2 and a by b is square root 2. So these two are equal to each other. So from this we saw that, okay, now simplify this. So b square equal to a into c, which is actually contradicting what we had assumed. We said that a and b have no relationship. They are co-prime. You cannot multiply a with something to get a b or b square. So this is contradicting what we had assumed. So we had assumed this is irrational. This is rational. So we are contradicting ourselves. So that is how it becomes. This is irrational. Yeah. Lot of interesting discussion happening in parallel. Not needed. Yeah. So was it clear? So I know this might sound a little tricky, but what I would, you guys are trying to flatter me now for no reason, and that doesn't impress me. The only way you can impress me is by focusing in the class and making sure that you grasp the concepts and solve the problems in an interesting way. Okay. So all right. Coming back to the point, this might sound a little cryptic, and that's okay. That's perfectly fine. Sometimes some of the concepts you might have to put 1 or 2 times effort to get a grasp of it, because once you understand it, then it will stay with you. Okay, so this is where the effort will go. Now you will have watch the video towards the end for 10-15 minutes and see if that is helping you, and if it is not, we'll meet again anyways. Yeah. Dikshita is totally exhausted. She's thinking what was going on for last 15 minutes. Okay. No, I know some concepts you'll find a little difficult to digest in the first go, and that is okay. I mean, that is where sometimes a little bit of extra effort is needed, because if we understand everything in one attempt, then either we are not getting opportunity to learn, or we are super intelligent like Einstein. And I'm not doubting that you guys might be much intelligent than me, but sometimes it takes little effort. That's what I'm trying to say. Yeah. All right. So that's what brings us to the end of the class. Quick summary is we learned what is irrational number. How do we deal with different operations? Guys, stop texting quickly. We learned what do you mean by the operation with irrational numbers. Do we have any generic thumb rule which says that okay, multiply two irrational numbers, you'll get this, you add, you'll get this? No, nothing like that. Only thing we know is if you add two irrational numbers, you'll get irrational number. If you subtract, you will get irrational numbers. But multiplying, there is no clear clue which says, Arav, could you please stop texting? So basically, you have to look at the examples and that will give you the clue. And you have to apply a little bit of thoughts to get a conclusion, because there is no one thumb rule which says that for every scenario, multiplication will give you a desired outcome. It is based on what are the inputs that you are dealing with. Yep. All right. So, yep. If you guys have any particular topic in mind, text me 2 days before the class. Don't say it on the day of the class. Okay. Next Saturday, I will choose the next topic. We'll move away from irrational numbers. We'll go to something else that we have not covered so far, or that might be new for you guys. But if you guys have any topic in mind, send me a text message or WhatsApp at least 2 days in advance, so that I can prepare and make sure that I cover everything that you guys need to know. All right. That brings us to the end of the class. I'll let you guys